morning everybody, and thanks for taking your time out on a Saturday morning to come and check out this home. Firstly, just want to thank the homeowners. It is very greatly appreciated, the fact that they've let us have a site day here and wander around and show you their homes. Wanted to take this opportunity to show everybody a few details on what gets covered up, just some important details on timber framing, vapor permeable membranes on the walls, UPVC windows, things like that. We took a real big punt yesterday, and I had a couple of my guys help me out the last couple of days to seal this up as best as we could, and we actually did a blower door test yesterday last minute, so we had a number to show you all, and I was terrified to start with, thinking it was going to be a bad one, but pleased to say we actually got 1.54 air changes an hour yesterday, so huge effort by the team and absolutely stoked with that number. Leading into it then, when you've got a super airtight home, obviously just making sure we get ventilation into these spaces so we haven't got unhealthy air quality. If you look up these little cylinders up in the wall next to the high level windows, there's one there and another one just up the back there as well. They are for decentralised HRV units, so it's a push-pull system. One will extract air out of the house while the other one brings fresh air in, just to make sure we've got some nice, healthy ventilated air coming in and out as well. Want to introduce a few people I've got here with me as well. I've got Jason over this side from Australian Window Solutions. These guys are the suppliers of the UPVC windows. Rebecca from Brock Fabel Designs over this side here. Rebecca is the designer for this project, and I've got Jess from Climasure over the far end. Jess's company, they supply all of the Clima membranes to all the blower door testing, and Jess is building science mad. So feel free to ask everybody questions as the day goes through.
Repeating what Luke said about thanks to the owners, not only for opening their house today, but also for taking a leap in terms of what they wanted to do. They had functional requirements, they had needs for their existing home and what they needed, but they also were dedicated to sustainability and dedicated to quality and without them, none of us would be here. So no good design ever occurs without excellent clients. We started here with this site, and what I always do is we just do a really detailed brief. There are requirements, functional requirements, you know, sleeping, eating, cooking, washing, those sorts of things. But there's also kind of the feel of the space, that how it works, you know, are we light and airy, are we private and, you know, secluded in a sense. Those things are determined between us as a team and the clients. And so what you see here today is really specific to them. And that's really important as well to note. I'm just going to have it talk about a little bit about the solar design and designing for site-specific spaces, okay? So part of all of that is we have a site, and you have a look at how we do this and how we do this best, and how we capture the sun, how we create a space that we can wrap, we can insulate, we can, you know, do a sustainable addition. We have a beautiful Tudor house at the front, which the client was very keen on keeping, and it's great, it's grand. We don't throw out everything, you know, that's not sustainable in any way, shape or form. So that is a dominant feature on this site. And the other thing is it's south-facing. So we've got the challenge, if you like, of a sort of a facing the wrong way for passive solar design. So what we did specifically with this build was to pull it away from the existing house to try and get some sun. The sun passes in this direction. This is all south. So hence the courtyards, hence the light over there, just to bring some light and some warmth into the space. There was a lean-to at the back, and it was quite dark at the time, and we were just really keen to get, and so that's why these sorts of spaces, this little courtyard here, that is for light. It's also for cross ventilation, okay? That's why there's a door open to get to those sorts of things. The other thing that was really critical for the client was solar panels, okay? And again, what happened initially when we first looked at this site is we found out that the neighbours next door were knocking down and building a massive residential development there. There were going to be 2-storey townhouses right on that boundary. So we spent quite a bit of time having a look at what was going on there to see what sort of impact that had on this particular site, particularly overshadowing. So the rake of the roof is for the solar panels. It is all functional, it looks great, but it is actually for a functional requirement as well, and it gives enough space for us to expand whatever that solar panel capacity is, and it also means that if there is overshadowing, which there will be, we're not then minimising the capacity of the solar. So the roof also formed a way of getting light, again, into this space, okay? It is southern light, it is not directional northern light, but it's a very gentle light, and it also is it's an outlook. It's an outlook to the sky, it's an outlook to trees. So that sweeping roof enabled us to get that light, because the moment we put a veranda across the back, which is a functional requirement, it's always good to have a veranda, it blocks the natural light coming in to this space as well.
Australian Window Solutions are a South Australian owned company. We manufacture here in Seaford, South Australia. I spend my week working quite often with the homeowner first up, and then they engage with a builder, or they engage with a designer, they engage with an architect to make it all come into fruition for themselves. So it's quite a process. From the time Luke might send me a quote, it could be a year until it actually becomes a reality. I guess with our windows, they're extremely high performing, being UPVC. They're naturally a thermally broken product. And I use that terminology only because that's an aluminium terminology, thermally broken. But our product does not transfer heat from the outside to the inside like an aluminium product will, and that's where you start getting the results that Luke's got on this job. Jess will be a testament to this as well. In the past probably 1 year, we've managed to pull together about 8 or 10 fully certified passive house builds as well, so we know we can get right up to that level by using the right glass combination. It doesn't have to go to triple glazing in Adelaide. Double glazing's fine. We can get away in the plains of Adelaide just using like a light bridge glass. But once we start getting to Yankalilla and colder places and Mount Barker and all that, it needs to be a premium Performer Tech glass. But it's all achievable, but it's no use having these double glazed windows and doors if the sunroof's open all of the time. So that's where Jess's wraps come in, and everything that the thermal envelope that Luke creates on the build. It all goes hand in hand together. You'll see foam sprayed in around all of the windows and doors just to seal off. Quite often on these old homes, you'd probably go into the old section of this house, take off the architraves, and there'll be a 1-inch gap all the way around that window, just hissing cold and hot air into the home all of the time. So even just little things on this job, you'll see the side ceiling clamps that we've put on. That's just to make sure it's 100% airtight. When you wind it in and clip that down, those double gasket seals are performing as they should. So you'll notice some of the smaller ones don't have that. So that's because they're within a tolerance range that we know that it's going to hit the mark on all 4 sides when you wind it in at night. But yeah, outside of that, if anyone's interested in catching up with myself, meeting with me in the showroom at Seaford.
Hi everyone, I'm Jess. I work for a company called Climasure and we're based in Hahndorf. And we are building envelope specialists. So I've worked with Luke for a couple of years now doing his blow door testing and providing wraps for all of his projects. He's sort of transferred to using the Clima brand exclusively, I believe. So yeah, we've worked together for a couple of years, and he's learned a lot in the past couple of years as he's embarked on this better building journey. I will say, yeah, these two work together very closely. Builder and designer, what I want to start with, collaboration is so key when you are building any project, but especially a better performing one. Things change, the knowledge base of the designer and the builder have to grow at the same time, otherwise you'll come up against problems. So any builders here, I would encourage you to develop strong relationships with your designers and architects and work closely with them through to the end of your project. It's definitely going to create better outcomes for your clients and healthier outcomes for your clients. Rising tide floats all boats, that whole saying. Everyone needs to be on board, and including your trades as well. All of your sparkies, plumbers, everyone needs to be on board and understand what the aim of the project is. So collaboration and communication is absolutely crucial in a project like this. Yeah, we did the blower door test yesterday, 1.54 air changes per hour at 50 pascals. To give you a bit of an idea of what that means, we've depressurised the building to 50 pascals. So at ambient, on a non-windy day, we're about 4 pascals pressure difference from inside to outside. We stuck a fan in that door behind you there, and we sucked air out of the building to a level of 50 pascals, and we get a score based on the volume of this space. So how much air we extract divided by the volume gives us a score of 1.54 air changes. A standard house at the moment in Australia is about 7 air changes per hour. A few years ago it was 15.4. So that standard level of air tightness is improving over time. The building code is requiring more insulation, it's requiring more air tightness. And even if we weren't going for a better performing building in terms of energy efficiency, because Luke and Rebecca, their clients go over and above what the building code minimum is. But even if you weren't going over and above the building code minimum, the building code is already requiring better windows and better air tightness. So you're changing the way air, heat and moisture move within a building envelope. And once you do that, you increase the risk of unhealthy indoor environments and you change the way a building dries. So water kills buildings. Buildings don't like timber, plasterboard, MDF, none of it likes water. It needs to be able to dry, otherwise it will deteriorate and create mouldy environments, and mould is very, very bad for your health. Some people are more susceptible than others to exposure to mould, but it can be devastating for some people, the impact it has on their ability to function. So that is why I do what I do. I care about a pretty building, but I care more about how they work, how they operate, and the health of the people inside them. So that's what gets me up in the morning. Started working for Climasure because it's attached to a builder who builds only high-performing homes. Certified passive houses included in that, and they sell these Pro-Clima wraps. So the blue wrap that you can see around this building is distributed by a company called Pro-Clima. So Pro-Clima are from Germany, distributed and manufactured and distributed directly out of Germany. And this is a class 4 vapor permeable membrane. So there's a lot of terminology around what this wrap is called: sarking, builder's wrap, by whatever you want to call it. We refer to it as a weather resistive barrier, or WRB. The whole point of doing it is to stop the frame from getting wet during construction. If you put the wrong wrap outside a timber frame during construction, and then the timbers get wet, or there's a plumbing leak, and then you clad it all up, it can't dry if that layer doesn't allow vapor to escape. So that's why this level of vapor permeability is important. More important in colder climates, where there's much more heating going on inside, and the vapor drive is much stronger from inside to out. The purpose of this wrap is primarily to protect the timber from weather during construction, and then it needs to perform during the life of the building as well to allow the building to dry. Up above us, you'll see there's a sheathing, which you might not be familiar with on a standard construction project. Above that is another membrane so this is called Extasana. This blue one up above us is Mento. They're basically the same product, but the Mento has got a reinforcement for roofs. It's a heavy duty product. And the reason that there's an OSB sheathing is because it's a lower pitched roof. So anything below 10 degrees needs a rigid sheathing to allow runoff. So the way that this roof is constructed is very different from a standard building code level roof. And I won't go on about it now, but if you want me to explain what's going on up there, let me know. I'm happy to have a chat to you about it. But it's all for drainage and ventilation.
Just to echo a point that one takeaway that I hope sticks in everybody's heads today: the building code is the bare minimum. It is the worst house that you can build without being illegal. So yeah, just as Jess discussed, a few timber framing details I want to point out, and just forward-thinking processes. One thing you might notice above the 2 flat rooms, the 2 rooms at the back there with the flat ceiling, that roof is pre-insulated above the air conditioner. Made sure that we did that. We wanted one continuous insulation barrier through the roof and down the wall, rather than traditionally something like that. An insulation contractor would probably come along and put it in the ceiling underneath it, but you end up with a break there, and obviously we didn't want an insulation contractor to rock up and get shitty because there was air conditioning duct in the way. So we pre-insulated that before then. The roof, the giant LVLs, they are at 450 centres. They are obviously our roof rafters as well as our ceiling joists. 450 centres have been closed up from your traditional 600s because plasterboard manufacturers, with the weight of an R6 insulation bat, they needed to be closed up to 450 to avoid any cracking or popping of screws. The wall frames, if you look close enough, if you know the difference between 90 and 140mm timber frames, external wall frames are beefed up to 140mm so they can fit an R4 HD bat in the walls. Then what we've actually done on the outside before we get to that, where the membrane gets to the bottom of the frames, we've used the Clima Orcon sealant on the outside and glued the wrap to the bottom of the wall plate. Then on the inside, you can see the grey caulking on the inside. We've actually polyurethane sealed the bottom plate as well, just to make sure there's no air getting in and out of the wall frame. All the windows have been taped with flashing tape on the outside to make it nice and airtight, and obviously to keep the water out as well if anything gets in there. Rule of thumb, we try and explain to all of our trades that the cladding and the roof is just there for aesthetics and assume that it will fail. So you want to have that membrane barrier on the outside so that if any water gets past it, it can still run out and it's not actually going to get stuck in the wall. Probably the last one to point out, on the outside of the wall, there's one panel of bass rock cladding that's been put on there. We just put on as an example to show you guys. It is a new cladding in South Australia. There's a couple of homes in Victoria that have been built with it. It's a mineral wall insulation with a fiberglass reinforcing. That'll get 2 coats of render and then a texture coat over top of that. So we've just put that on to show an example to see what the cladding's going to be. That's up to the veranda level, and then there's some WeatherTex cladding going above that. So, but you can see the ventilated cavities with the counter battens on the outside of the walls anyway. There was a couple of questions people asked on the way in about the mesh on the bottom. There's a few bits on that. It's obviously not finished yet, but that will get pulled up the front of the counter battens and stapled on, just so that any bugs and vermin can't get up that cavity, but it can still allow the walls to breathe.